That gold jewelry you're wearing? It might contain atoms from an exploded star that died billions of years ago. The cosmic story of gold isn't just fascinating. It explains why this rare metal has shaped human civilization more than any other element. You see, unlike elements like carbon or iron, gold wasn't formed in the everyday lives of stars. No, gold requires something far more cataclysmic, the violent collision of neutron stars, or a rare type of supernova. In these cosmic crucibles, where temperatures reach millions of degrees and pressures are unimaginable, atomic nuclei are forced together to create heavier elements like gold. These gold atoms were then scattered across space, eventually becoming part of the dust cloud that formed our solar system. So that gold ring on your finger? It's literally stardust, the remnant of cosmic violence that occurred billions of years before humans ever walked the Earth. On our periodic table, gold sits quietly as element 79, symbol O, from the Latin aurum, meaning shining dawn. But there's nothing quiet about gold's properties. This dense, soft yellow metal is remarkably malleable. A single ounce can be stretched into a wire 50 miles long or hammered into a sheet so thin it becomes transparent. Have you ever wondered why ancient gold artifacts still shine after thousands of years? Gold doesn't react with oxygen, it doesn't rust or tarnish. This chemical nobility, this resistance to corruption, is part of what makes gold special. In a universe where entropy reigns and most things decay, gold remains unchanged, unaffected by the passage of time. It's as if gold exists outside the normal rules of our physical world, a quality that hasn't gone unnoticed by humans throughout history. From the earliest civilizations to modern nations, gold has been synonymous with wealth, power, and prestige. The ancient Egyptians called it the flesh of the gods. The Incas referred to it as the sweat of the sun. For thousands of years, gold has been the universal currency, a store of value that transcends borders, languages, and cultures. Why? Because of its rarity, its beauty, and its permanence. When archaeologists uncover gold artifacts from ancient tombs, they shine as brightly as the day they were buried. This permanence made gold the perfect symbol of immortality and divine power. From King Tut's mask to the treasures of El Dorado, from Spanish galleons to Fort Knox, gold has driven exploration, conquest, and commerce. Think about it. How many other substances have caused humans to cross oceans, start wars, and build empires? Few materials on Earth have influenced human history as profoundly as this element born in the stars. So where exactly do we find this cosmic treasure on our planet? Gold is scattered throughout Earth's crust, but in concentrations so small that finding economically viable deposits is like searching for cosmic needles in a terrestrial haystack. The most common source is gold ore, natural mixtures of minerals containing gold alongside quartz, pyrite, and chalcopyrite. These deposits formed millions of years ago when hot, mineral-rich fluids circulated through cracks in the Earth's crust, cooling and depositing gold in veins. But gold is also found in rivers and streams as alluvial deposits, created when erosion and weathering break down gold-bearing rocks, allowing water to carry tiny particles downstream. These are the deposits that triggered gold rushes from California to Australia, where prospectors with simple pans could separate heavy gold particles from lighter sand. The journey from Earth to jewelry box is an epic one. Modern gold mining is a far cry from the simple panning of gold rush days. Today it involves massive operations that move mountains, literally. In open-pit mines, which can be over a mile wide and half a mile deep, giant excavators remove tons of ore that contains just a few grams of gold per ton. Think about that scale for a moment. Processing 1 ton of ore might yield enough gold to make a single wedding ring. Underground mines follow veins of gold-bearing rock, sometimes reaching depths of over 2 miles beneath the surface. Once extracted, the ore undergoes crushing and grinding to release the gold particles. Then comes the chemistry, processes like cyanidation, where a dilute cyanide solution dissolves the gold, allowing it to be separated and recovered. The final step is refining, where gold is melted and purified to remove remaining impurities, resulting in gold that's 99.99% pure. Pure gold, what we call 24 karat, is actually too soft for many practical applications. If you had a pure gold ring, it would bend and scratch with everyday use. That's where alloys come in. Mixtures of gold with other metals that enhance durability while maintaining gold's desirable properties. The familiar yellow gold in traditional jewelry is an alloy of gold, copper, and silver. White gold, increasingly popular in modern jewelry, combines gold with metals like nickel, palladium, or zinc to create a silvery appearance. Rose gold, with its warm pinkish hue, is an alloy of gold and copper. And green gold, sometimes called electrum, is a natural or artificial mixture of gold and silver. These variations aren't just about aesthetics, they're about engineering materials with specific properties. The carat system tells us the gold content. 18K gold is 75% pure gold, 14K is 58.3%, and so on. While most people associate gold with jewelry and wealth storage, this element plays crucial roles throughout our modern world that most never see. Gold is an excellent conductor of electricity that doesn't corrode, making it invaluable in electronics. Every smartphone contains about 50 milligrams of gold in its circuitry. Without gold, our digital revolution might have short-circuited. In medicine, gold's biocompatibility, its ability to exist in the human body without causing harm, makes it perfect for dental work. Those gold crowns aren't just for show, they're durable and non-reactive. Gold compounds are even used to treat certain forms of arthritis and cancer. In aerospace, gold's ability to reflect infrared radiation makes it perfect for protecting spacecraft and satellites from the extreme temperatures of space. Those iconic gold visors on astronauts' helmets, they're coated with an ultra-thin layer of gold that blocks harmful solar radiation while allowing visibility. The technological applications of gold extend far beyond simple electrical conductivity. In the world of nanotechnology, gold nanoparticles are revolutionizing medicine with targeted drug delivery systems and ultra-sensitive diagnostic tests. A solution containing gold nanoparticles can change color in the presence of specific DNA sequences, allowing for rapid disease detection. In catalysis, the science of speeding up chemical reactions, gold nanoparticles show remarkable efficiency at facilitating reactions at lower temperatures, potentially saving enormous amounts of energy in industrial processes. Even in environmental technology, gold plays a role. Certain gold catalysts can convert carbon monoxide into harmless carbon dioxide at room temperature, with applications for air purification. And as we push the boundaries of quantum computing, gold's unique properties at the nanoscale may help build the computers of tomorrow. The element that adorned ancient kings now sits at the cutting edge of our technological future. Why does gold command such extraordinary value? The answer lies at the intersection of cosmic rarity, human psychology, and practical utility. First, gold is genuinely scarce. All the gold ever mined throughout human history would fit into a cube about 70 feet on each side. That's smaller than a tennis court. Its extraction requires enormous effort, moving tons of earth and rock to recover mere ounces, using complex and expensive processes. But scarcity alone doesn't explain gold's enduring value. Gold's physical properties, its resistance to corrosion, its malleability, its distinctive color, make it uniquely suited for both adornment and practical applications. And then there's the psychological component. For millennia, humans have associated gold with status, power, and permanence. This cultural programming runs deep in our collective consciousness. Unlike fiat currencies that can be printed at will, gold's supply increases by only about 1 to 2% annually through mining. This relative stability has made gold a traditional hedge against inflation and economic uncertainty. As we've journeyed from exploding stars to modern technologies, we've seen how this cosmic visitor, this element forged in stellar cataclysms, has shaped human civilization. Gold's story is a perfect example of how the universe's physical laws and Earth's geological processes created something that resonated deeply with human psychology and needs. Our fascination with gold isn't just cultural, it's almost hardwired into us, a recognition of something truly special in the fabric of reality. As we look to the future, gold will continue to play its dual role, as both a symbol of enduring value and a practical material in our most advanced technologies. And perhaps someday, as we venture beyond Earth, we may find new sources of gold on asteroids or distant planets, continuing our cosmic connection with this extraordinary element. The next time you see gold, whether in jewelry, electronics, or investment portfolios, remember, you're looking at the legacy of exploded stars, the witness to human history, and possibly a key to our technological future.